Welcome to the fourth video of the Cupertino Robotics Project CNC. In this example, we're going to fabricate a simple plate. In other words, this will be a flat piece and it will have a, not rectangular, but it's going to have a complex shape. The approximate runtime on this is going to be 20 minutes. We appreciate those people who made it possible, the Gene Haas Foundation, the Fremont Union High School Foundation, Tormach Corporation, of course, Dassault Systems Solidworks for the CAD and CAM, and also two of the mentors in the lab, Doug Lowe and Dave Visant. So these are the 6 videos that we have so far. I hope you've gone through all of the first 3 before you try with this the simple plate. If you're just jumping into this video 4 without doing the other 3, I think you're going to not gain a lot from it. So let's go back and do the ones that you haven't done before we do this one. This is a familiarization effort, and so you're not going to be an expert in CNC machining, and you will not be competent. You must not try to do this on your own. Okay, so before you load this, the G code on the machine, make sure that you work with a trained adult mentor, and make sure that mentor is there when the machine is running. Otherwise, you can hurt yourself, hurt other people in the lab, or damage the machine. So we're going to do something and cut out a simple plate. This is what the plate looks like. It looks like kind of a hot dog with rounded ends. Okay, and we'll find that trying to do this without a CNC would be very difficult, because it's hard to cut those rounded ends, so those little half circles out there. We'll use Solidworks CAD to design. We're going to design first a rectangular plate, and then we'll design the thing that we want cut out from that plate. We'll use Solidworks CAM to create the G code by using a new feature of the CAM, which is the boss feature. And then we'll run this and actually see this thing built. So without further ado, let's go over to SolidWorks CAD and start designing. This is a first video of a 2-part series. It talks about how we can use the mill to cut shapes out of a plate. So we've been talking about milling holes and slots and things like that. We're going to actually use the mill more like a router. So in order to do so, let's go through and sketch out a really quick part. And the part's going to look like first thing I do when I sketch this thing, I'm going to sketch the piece of material I'm using to cut the part out of. Okay, so it looks like this, and I'm just going to say it happens to look like kind of a 2 by, let's say, 10-inch piece. Okay, so it looks something like that. So this is arbitrary in here. I want to make it about 1/4 of an inch, so I will do this. I will put a feature, and I'll do this, and I'll make it 1/4 of an inch. So that's the piece I want to cut my shape out of. Okay. Now, what is the shape? We'll talk about more exotic shapes in a moment, or in the second of these videos. But let's put a shape that basically is just kind of a little oval thing. So let's sketch that shape. We're going to sketch it right on top of here. And I'm going to just use that slot tool. And I'll make something. So I want something like this cut out of here. How wide do I want it to be? Oh, let's say it's 1 inch. And then I want this thing to be, about 8 inches long. That's fine. Now, something that's really important here is to make sure that that we're going to cut out this sketch, this piece that looks like this. Make sure you have lots of space over here for clamping, because you have to hold this thing down when you work. So you need to clamp it down. You need to think about work hold. It's a general tool. It's a general issue of work holding. Okay, so that's all I need for this if I want to get this kind of this shape. So what I'm going to do now is I'm going to go to the cam. I'm going to flip over to the cam tree so I can see what's going on. Let's redefine my machine. Should be all old stuff now. We define the machine. Let's define that. Let's select that tool crib, and let's make sure we don't let them put any additional tools in our tool crib by checking this box. Okay. The post processor, it tells us we don't have one, as it has before. So let's go through and select the Tormach Path Pilot. And then I think we're done with that. Okay, let's look at our stock manager. Okay, the stock manager looks like this. And so I think we're okay on the stock manager. Okay, so it says that this is the piece we're going to cut it out of. And so we're there. Okay, let's do the coordinate system. The coordinate system, I'm going to use that upper left hand right over here. Okay, and again, the Y's in the wrong direction, so I'm going to tell Y to come down on this edge and then flip it over. So now I have the coordinate system running just fine. So we have that. And see, after a while, this becomes almost muscle memory. So let's look at the mill setup on this thing. And I want to do a mill setup so it's on this face, because that's where I'm going to be clamping it. And that looks good. Okay, so basically I have it on here, but I don't, how do I get the parts? Well, I'm going to do it a little bit differently, the features. I'm going to go into mill setup, and I'm going to go down to 2.5 axis feature, and I'm going to look at this. The 2.5 axis feature says I can do this as a pocket, or I can do it as something that's called a boss. And a boss is basically just to cut it out. Okay, it wants me to tell it what are the sketches I wish to use. And this was a sketch. Sketch 1 was the sketch that we used to define the rectangle, the part we're going to cut it out of. And sketch 2 was actually the part that we want to cut out. So we're going to do sketch 2 on that. Okay, so this is basically what we're trying to cut out. Now let's look at the end conditions. And the end conditions are going to tell us how deep we're going to cut. Now, what it says is we're going to cut, that defaults for some reason to 0.394. But if we look at this closely, what we're finding is that we're cutting below this piece. And it's okay to cut a little bit below the piece because we have to have a piece underneath this, a sacrificial piece that we could cut into. We don't want to cut into that beautiful plate on the mill. So, but we don't need to cut this deep. So I'm going to go over here to this, and I'm going to cut 1/100th of an inch or 10,000ths of an inch deeper than I need to. So that's what I'm going to be cutting. So I would be cutting like that. Okay, so this is basically the piece I'm going to cut out, and I'm going to cut it out to 1/100th of an inch deeper than this piece of material. Okay, so we have that. Let's generate a path. And what it says is it's going to cut it out with a 1/2 inch end mill. That's a tremendous amount of material that we're wasting on this thing. So I'm going to do it a little bit differently. Okay, and I'm going to look at this and edit the definition a little bit. And I'm going to change the tool that it's using. So see, it's using a flat end mill, and it's a 1/2 inch. I'm going to go into our tool crib, and I'm going to say I don't want to use this tool, I want to use this tool. So I'm going to select the 1/8 inch, which is that nice thin one, and then I'm going to select that one. So, and it says, do you also want to change the holder? And the answer is yeah. Okay. So now we've changed this now to an 1/8 of an inch tool. So there it is. So let's look at our paths. And I'll do this and pop this for the path. So this is what it looks like as it's going around. So let's generate the tool path. And so there's the tool path. And what we see is what it's going to do. It's just going to run that 1/8 of an inch mill around here. Then it's going to go a little bit deeper, run it around here, and it's going to cut it out. And it's going to cut it out like a router, basically, is what this thing does. So we have that. We can look at the simulator, but let's just step through and see what it looks like. So I'm going to step through the tool, and then let's get some detail on this, if I can get this thing flipped up. Okay. If you look in here, it's going to take 1, 2, 3, 4, 5. Those are the steps it's going to take, and they're all going to be that slot, that rounded slot kind of a step. So if I were to back out, and then I'm going to go through and look at the, I'm not going to go quite that fast, and then let's run it around. See what it's doing? And it's done. Okay, so it basically cut it out. And so it'd be interesting to see what this looks like. And so I'm going to go here, and then I'm going into the post processor. And this is not part 1. Let me just call it. This is, I think I called it plate. I'm going to do simple plate. So I'm going to save that. And then let's post-process it. Okay. And look, it only took 1,600 bytes to cut that thing out. So we're good. And then we can take a look at the G-code. And it's not a lot of steps. And once again, you can see what it's trying to do just by looking at the colors. This is basically one path through it. This will be the second path through it, and so on. So you get the red and the greens, and the red and the greens as this thing goes through. And you can see, for example, here on this piece, it says that what we're going to do is we're going to go down 62 thousandths. Next time, we're going to go down here, down into 111 thousandths, and so on, as it just keeps on cutting deeper and deeper into it. Okay, so I think that's a nice little explanation how we can do this different kind of milling. And this different kind of milling is called a boss, and the boss basically cuts things out. This begins the fabrication of the simple plate. Please don't get confused with the fact that this the aluminum plate already has part of this simple plate built into it. I made a mistake when I started this video in the beginning because I didn't turn the camera on. So I had to stop the recording and restart with the part of the plate already milled. Once you've milled something, you can't just start from where you left off. You have to remill it. I thought about using a fresh piece of aluminum, but as any good machinist, I'm fairly cheap, and I wanted to reuse what I had. So we'll find that we're going to follow the simple plate of the original mill line, and then we're just going to follow it around, and we'll have plenty of time to cut new aluminum, fresh aluminum, as we complete the simple plate. I'd like to point out a couple of things here. Number one is there is a brass tube that is shooting a high-speed stream of air and the air is also mixed with the lubricant. So this is a mister. And so the purpose of this is twofold. One is to, actually it's threefold. The first one is to shoot the air into the track so that we pick any of the chips out of the track. The second one is to lubricate the tool as it's moving against the aluminum. This keeps the tool so it'll cut smoothly and also extends the life of the tool. And the third part is as we push the lubricant against the end mill, the tool in this case, is that we will cool it, and so that will greatly reduce the chance of getting any welding between the tool and the aluminum. So we're just going to follow it around and watch the mister follows as it goes around here. Now, the other thing I'd like to point out is that you'll see two pegs that are in the foreground. And the pegs are important because they keep the aluminum parallel to the x-axis of the mill. So when we cut here, we're going to cut the piece out of the aluminum so that the piece will also be parallel to the x-axis of the mill. It just keeps everything aligned. And then another piece that we'll see is that there are 4 strap clamps that are holding this whole thing down, holding the aluminum plate down. And so the strap clamps are in the corners, and the purpose of these strap clamps is to make sure things don't move as we're cutting. We just finished the first pass, which is cutting 50 thousandths, and we noticed that the mill took a little jog as it began the second pass. This little jog is important because it allows the mill to clean the chips out of the trough, and also just allows it to realign. So we're moving around here, and we're cutting now the second pass. This begins the last pass, and in this pass we're actually cutting through the aluminum all the way through, and we're cutting against a piece of double-sided tape that's holding the aluminum to a polyethylene plate underneath it. So we're almost done with the part. How cool.